Dr. J. 4.2 today, multiplying and dividing fractions. I didn't have enough room to write the official title, so I just wrote multiply and divide, but I think you get the point. I'm actually not going to start with multiplying and dividing. I'm going to start with a comment. In 4.1, the introduction, it was okay to have answers such as, I don't know, 12 over 9 or something like that. Or, 4 over 8, something like that. These types of unsimplified fractions were okay. Yeah. And not only were they allowed, but they were actually encouraged in some of the problems in 4.1, where I would actually give you a problem and I'd actually wanted the answer written this way or written this way. That was only temporary. That was just to visualize the concept of a fraction, Something like 12 over 9 would be, oh God, why did I pick this? Something like 12 over 9 back in section 4.1 would be something like 9 is like one of the hardest fractions to make. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why did I pick 9? But okay, you get the idea, right? 4, 5, 6, 7, 8, 9. Okay. All right. Again, we're not doing this today, so it doesn't matter. But if you had something like this, and you had 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, I got it right. So there's 9 out of 9, and then 3 more. Shade in 3 more. And I asked you what this is representing. The fraction is there are 9 sectors or 9 pieces of each pizza or pie or whatever you want to think of it as. So this is 9 ninths and this is 3 ninths. So altogether that's 12 ninths. Yeah. Or something like this. So an improper fraction, 12 over 9, represents more than 1 unit. A proper fraction represents less than 1 whole unit. So this would be 4 out of 9. 4 out of 8. So this has a denominator of 8 because the pie has been cut into 8 pieces. And I'm shading 4 of the 8 pieces. And so this would have been okay, unsimplified. It would have been okay to leave the answers like that. Some of you might have simplified them just out of habit. But in 4.2, I'm going to insist that you do that. And so something like this, 12 ninths, would actually be written as 4 thirds. Yeah. And the reason is because this is a third. You can think of the fraction as being cut into thirds, 1, 2, 3. So this is 1/3. I'm using a different color now. And then over here, you can think of, sort of tear down these walls here. And think of that as being cut into thirds. Yeah. And so this is 1, 2, 3 thirds plus 1 more third. And so the simplified answer is called 4 thirds. This is what we call reduced to lowest terms. Yeah. Reduced to lowest terms. So that would be what 12 ninths reduces to. And I think this one goes without much saying. We talked about this last time. I could just remove these boundaries here and just shade half of the circle. So instead of thinking of this as 4 out of 8 or 4/8, I could reduce this down to 1 out of 2 or 1/2, and that would also be reduced. We often just say reduced or we say simplified. So these all mean the same thing. Lowest terms, reduced to lowest terms, simplified. Those are all synonyms for making the answer look as simple as we possibly can. So, for the rest of the semester, all fractions must be reduced to lowest terms or simplified. All right. Now, today I'm just going to say it every 5 minutes. I'm going to say reduce, simplify, reduce, simplify. Eventually, I'm just going to stop saying it. I'm just going to expect that if you're doing a math problem in my class, you need to simplify your answer. All right. I might remind you of it occasionally because I like you guys and I want you to get the right answer. But ultimately, the onus is on you to know that in mathematics, you have to simplify your answers. All right, so let's do an example. Sorry. And we could probably do more than one per problem today. I think we can get away with a little bit more than that. Okay, now I want to say something about this procedure. There is a quick way to do it. Yeah. And the quick way is like this. 6 goes into 48 8 times. Yeah. That is true. So you can just do it with mental math. You know, you could say 48 divided by 6 is 8, and then just write this as 8. Yeah. The problem with this, the quick way, is dangerous. And I don't just mean in Math 65. I mean this method is dangerous in Math 65, Math 54, Math 40, Math 10, Math 12, Math 5, Math Calculus 1A, 1B, you name it. It's dangerous all the way up the ladder of mathematics because 50% of the students will write the answer as 8. Yeah. The answer or the result is not 8. Yeah, it is 1/8. Yeah. Now, I mean, if you do it correctly every single time, then that just means you live dangerously and you get away with it. Yeah. I mean, you might drive on the freeway at 100 miles an hour all the time with no seatbelt and nothing goes wrong, right? I mean, that could happen. But that's not the business I'm in. I'm not in the business of encouraging you to do it this way. I'm in the business of teaching you the right way to do it. Once you get so good at it that your confidence level is through the roof, then you can live dangerously. And you can do this correctly and get it right most of the time. All right. I'm not going to do the dangerous way. I'm going to show you the right way to do it. All right. So the proper way to do it, I call this the safe way. The safe way is to use factoring. If possible, prime factoring is the best. Sometimes I won't go all the way to primes, if I notice that, there's a quicker or, a just as effective way of doing it. But I'm going to go ahead and do prime factors today. So 6 is 2 times 3. All right. 48. 48 is 2 times 2 times 2. That's 8. Times another 2 times 3. You might want to do that with mental math just very quickly. I told you to memorize this. This is 8. Right? 2 times 2 times 2. And then 2 times 3 is 6. And 8 times 6 is 48. Yeah. And again, that's mental math. 8 times 6 is 48. And what we're going to do is we are going to cancel every factor that equals 1. These are special forms of 1. And so those cancel off. So I have 1. Yeah. If everything cancels, put a 1. Because it's essentially like you're saying 2 divided by 2 is 1. 3 divided by 3 is 1. And so what I have is I have how many 2's left over? I've got 3 2's left over that did not cancel. Here's the ones that did not cancel. And then the final answer is 1 over 8. So that's the result. This is what we call a simplified fraction, 1/8. All right. So that is the safe way. And I know you're probably sitting there going, really? You want me to do all that extra work? I'd much rather just do it the dangerous way. Right? Well, you know, that's fine. You're going to take a risk. Yeah. Let's try this one. 80. All right, so 80 is 8 times 10. I'm just going to do the top first. 8 is 2 times 2 times 2. That's 8. And 10 is 2 times 5. All right, now make sure that you got the right number of 2's. You got 2 times 2 times 2. That's the 8. And then you got 2 times 5. That's the 10. All right, 128. 128 is 64 times 2. 64 is 8 times 8. And then times 2. So the 64 becomes 8 times 8. And now each one of these 8s becomes 3 2's. So altogether, I'm going to have 6 2's. 1, 2, 3, 4, 5, 6, plus this extra 2, so 7 2's. And now cancel all the special forms of 1. All right, cancel 1, 1, 1, 1. So technically, this is 1 times 5 on top, and then 2 times 2 times 2. If you still have a numerator, you don't need to put the 1 anymore, because we all know that 1 times 5 is just 5. So that's going to be 5 over 8. The top is, the numerator is 1 times 5, which is 5. The denominator is 2 times 2 times 2, which is 8. Okay. So again, this is the safe way. It's not the fastest way. It's not the freeway, you know. It's the safe way. It's the slow and steady, right? And remember I don't know if you remember the story of the tortoise and the hare, you know. The rabbit or the hare was trying to run really, really, really fast and they lost. You know? The hare always loses that race. Slow and steady wins the race. Let's try another one. Notice the denominator is prime. Yeah, 17. So if either one of these numbers is prime, either the numerator or the denominator, then that's always going to be one of your factors. Now, I just guessed 17 times 11. I should probably double check that. You can use a calculator if you really want. I didn't bring my calculator today, so I know that if I have a prime factor or any prime number in the numerator or the denominator, that must be one of the factors. Otherwise, it's irreducible. And I'm not very often going to give you a problem that's already irreducible. You know, I'm not going to tell you to reduce something that can't be reduced, at least not now. I mean, someday I probably will. Yeah. So 17 goes into 18 one time. 1 times 17 is 17. Subtract. Bring down the 7. 17 goes into 17 another one time. Subtract. Remainder 0. Check. It is 11. It was just a lucky guess. Okay. And so these cancel. So it's technically 11 over 1. If the denominator is 1, omit it. So just say 11. Yeah. This literally means 11 divided by 1. 11 divided by 1 is just 11. All right. If the numerator is 1, do not omit it. So you might want to make a note of that. I think I already did, but I'll do it again. Note, if the numerator is 1, do not omit. You are required to put it if the numerator is 1. All right, 16 twelfths. 16 twelfths. You do not have to use prime numbers. I encourage you to use prime numbers, but it's not always necessary to use primes. How do you know? Well, you essentially have to do the problem twice. Do it once with all prime numbers. Do it again with non-prime numbers. If you get the same result, it means that it was not necessary. All right. I know a lot of people don't want to do the problem twice, but try it again. 16 is 2 times 2 times 2 times 2. That would be using primes. And then 12 is 2 times 2 times 2 times 3. Sorry, too many 2's. 2 times 2 times 3, that's 12. And this is not necessary. It's too much work, but it's still correct. Cross off the 2's, and you're still going to get the same result. All right. So if you want to know whether something is necessary, do it both ways, and if you get the same result, well, then it was not necessary. It was sufficient, but not necessary. Okay? There are a couple free answers. Couple free answers. I don't know if I will put these on a test or not. They're a little bit too easy, but I'll definitely put them in the homework just to give you some free homework points. So these are essentially free answers. Any number divided by 1 is just equal to itself. Yeah, that's a free answer. And then any number divided by itself is just equal to 1. So these two types of problems are essentially freebies. Yeah, just take the free points. You don't even have to show any work. Okay. Not that I'm grading your work anyway, but you know, someday we might be back in school and I might be actually collecting your papers and things like that. All right. And if you're taking good notes, you want to be showing your work anyway so that you can retrace your steps, because you know all of this stuff will come back to you in December when we do the finals. Okay, so those first 3 problems were really just a kind of icebreaker. You know, let's just get the ice broken. Now we're going to move on to multiplying and dividing. I messed up the camera. Come on. Is it back? I can't tell. Everything looks blurry to me. Oh, good. It's back. All right, so here's the idea with multiplying. Don't actually multiply. Until the very end, and only if necessary. In other words, we're not actually going to multiply. All right, what you're going to do, instead, factor and reduce. So if I give you a problem like this, all right, don't actually multiply. Because if you actually multiply, you're going to get 5 times 4. This is 20. Don't actually do it. And then you're going to get 12 times 15. Don't actually do it. Just write it. 5 times 4. 12 times 15. And instead of multiplying these, factor them. So 5 times 4 is 5 times 2 times 2. 12 times 15 is 3 times 2 times 2 times 3 times 5. That one's a little bit of a mouthful. The 12 is 3 times 4, but I already factored it to 2 times 2. I could have just left it as 4. And then the 15 is 3 times 5. All right. The 5 is already 5, and then the 4 is 2 times 2. And then reduce. In other words, cancel everything you possibly can. So what do we got? We got a 5 and a 5. And we have a pair of 2s. Since everything canceled in the numerator, you got to put that 1 there. All right, you can never leave the numerator of a fraction blank. In the bottom, you have 3 times 3. Now multiply, because it's now necessary to multiply. So 3 times 3 becomes 9. So the answer is 1/9. Much easier. That process, even though it looks kind of exhausting, that process is much easier than actually going 5 times 4 and then going 12 times 15. That would be a disaster. Although it would still be 1/9. Yeah. And no matter what, don't use a calculator or a cell phone, because they will never give you the right answer. Ever. Ever. Calculators will give you decimals. You know what this would have came out to be? 0.11111111111. You would have just saw a whole infinite list of ones on your calculator. You would have never known that that was 1/9. Calculators are pretty much only good for money, percentages. Calculators work pretty good in percentages. We'll get there eventually. Yeah. Things like that. Fractions and calculators don't typically get along very well. So let me make some more space. Multiply 1/3 times 6/7. Now, most math mistakes are from bad training. You were trained badly when you were younger. And one of those trainings that I was actually trained that way too as a young child, where you cross off the 3 and then cross off the 6, and they do this thing called cross canceling, and it's just that's the worst idea anybody ever came up with. All right, I mean it's a quick fix, right? I mean, it quickly gives you the answer, but it completely undermines your success, and it causes, a cancer that grows. Mathematically speaking, it doesn't really cause cancer, but mathematically, this just grows inside of you, and then by the time you get to college, you're wondering why math is so hard, right? Why is math so hard for me? Well, because they planted this disease inside of you when you were younger, and now you've got to deal with it, right? Now you got to, go through a bunch of therapy and things to finally get over these things. And so I just want to make it very clear that if you already know the answer and you've done it the quick way, that's a bad seed. That bad seed will come back to haunt you. Just multiply straight across. Don't actually multiply. Use prime factorization. I'm actually going to go down here. 1 times 2 times 3, that's the 6. You don't actually have to put the 1. And then 3 times 7. And then cross off the 3's. And now 1 times 2 is 2. And then the denominator is just 7. And so you get 2 7ths. So why do I make such a big deal about not doing it the other way? Because the other way will give you the same answer sometimes, but not all the time. It's about a 50% success rate doing it the quick way. And I don't know if, I've made this clear, but 50%, that's an F, right? I mean, if you're only getting the right answer 50% of the time, you're going to fail. If you do it my way, you have like a 99% success rate. I mean, your success rate goes almost to 100% by doing it this way. I mean, nothing is ever 100% successful because we're humans, and humans screw up all the time. So, all right. Example 6. Okay. Again, multiply. I didn't put the instructions, but they're all multiply. All right. If you see a whole number or an integer, there is an invisible 1 in the denominator. That is very important because I don't want you going like this. No way, don't do that. Don't go 21 times 56. That will screw everything up. The 21 multiplies by the 31. And the denominator gets multiplied by 1. Now you want to use prime factorization. So 21 becomes 3 times 7. 31 is already prime. So you can't break up 31 anymore. There's a 1 in the denominator. You really don't need to put it. But I did anyway. 56 is 7 times 2 times 2 times 2. Or if you prefer, in this problem, you can just put 7 times 8. How do I know I don't have to go 2 times 2 times 2? Well, because there are no 2's in the numerator. Yeah. If there were any 2's in the numerator, then I would have to go 2 times 2 times 2 times 2. Or 2 times 2 times 2. It looks like I'm only going to get 1 common factor, so that cancels off. That becomes a special form of 1. And then our final answer, I'm running out of room, so I'm going to move over, is 93 over 8. We're not doing any mixed numbers in this section. So don't make into a mix unless specified. So if the problem says mixed, specifically says mixed, then go ahead and do it. Otherwise, leave it alone. All right. If you really want to know what it is, just out of curiosity, you're curious what's 93/8? 8 goes into 93 11 times with a remainder of 5. So if you're curious, it would be 11 5/8. If you're not curious, if you don't care, then just leave it as 93/8. I mean, I want you to leave it as 93/8, but I mean, some people want to know, what's 93/8? What does that mean? It's 11 5/8. Okay. So here's a special case. It's essentially another free answer. I don't recommend going like this, cross, 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 the cross-canceling thing. I have seen people go like this and go like that and get the wrong answer. Yeah, incorrect. All right, the correct way to do it is 8 times 15, 15 times 8. Okay, and then that is 8/8, which is 1, and then 15 over 15, which is 1. So technically, this is just 1 times 1, which is 1. Yeah. Or you could go like this, 8 times 15, 15 times 8. You could get 120 over 120, And you could go 120 divided by 120, and you're still going to get 1. Yeah, this is the long way. All right. But definitely don't put 0. All right, don't put 0. It's 1 times 1 is essentially what this is, which is just 1. That's the safe way. All right, that ought to do it for multiplication of 2 factors. Let's do one with more than 2 factors. More than 2 factors, multiply, and then reduce your answer. Or I could say reduce to lowest terms. So 8/5 times 2/7 times 4/3 times 3/4. Sorry, I read it upside down. So you're just going to go straight across the top, straight across the bottom. If you do want to go a little bit faster, you can start factoring these earlier. So you're already kind of thinking 8 is going to be 2 times 2 times 2. This one's already a 2. That one's already a prime. That's a 3. So there you could start doing this early. 5 is already prime. 7 is already prime. 4 could be 2 times 2. And unfortunately, you only get a couple 2's to cancel. So 2 pair of 2's cancel. And that's as good as it gets. You're going to get 12 over 35. Over 35. Again, I did that with mental math. 2 times 2 is 4. 4 times 3 is 12. And then 5 times 7 is 35. I'm not going to do many more of those just to show you that you can extend this. You can have 3 fractions. You can have 4 fractions. I don't know, there might come a day where we have 5 or 6 different fractions. For today's lesson, we'll just stop at 3. Okay, we have negatives. So let's review the rules of negatives. If you have a negative times a positive, you already know your answer is going to be negative. So now ignore it and just do 7 times 12 and 8 times 7. So decide right away, right when you look at the problem, is my answer going to be positive or negative? Once you know, in this problem, it's going to be negative. Now you can ignore it and just do the rest of the problem. 7 times 12, so 12 is 4 times 3. Or if you prefer 6 times 2, you could do that as well. I like 4 times 3. 8 is 4 times 2. And then 7 is still 7. Now I could keep going, but it's not necessary because I have a matching pair. So if you have a matching pair, you can cancel them without continuing to factor. If you didn't have a matching pair, of 4s, then you would keep going, keep factoring down to 2s. All right, and then cross off the 7s also. I guess I could have done those early if I really wanted to. I don't recommend doing it way back here because you could do it too soon and then wish you wouldn't have done that, right? It's hard to unring a bell, right? Once you've already rung it, it's too late to stop the ringing, you know? And so you have -3/2, or you can write it as -3 on top and then +2 on the bottom. I mentioned this in the introduction. I would also accept the negative on the bottom, but I'm not going to write that because I don't want to encourage you to do that. But technically it's legal, so I'd have to allow it. All right. I prefer either out in front or up top. Okay, those are the two places for a negative. All right, negative times a negative. I already know my answer is going to become positive. Okay. If it's positive, you do not even have to put a sign. Positivity is implied. When you look at a number, it's implied that that number represents a positive. So now I'm just going to go 5 times 18, 6 times 25. All right. 18 is 6 times 3. 25 is 5 times 5. I already have a matched pair of 6s, so I don't need to keep factoring. If I didn't have at least one match, I would keep factoring. Excuse me. Okay, so you got a matched pair of 5s. That's 1. That's a factor of 1. You got a matched pair of 6s. That's also a factor of 1. I don't have to actually put the 1 because I still have some leftovers. We often refer to those as the leftovers. We only put a 1 if there are no leftovers. I'm getting really lazy with the instructions here because they're all the same instructions. Oh, 14/9. I don't know what's going on. I feel like we've done this before, but whatever. A lot of these problems look very similar to each other. This is dangerous because of the way it's written. You might think it means subtraction. Okay, but if you put a number, in particular a fraction, out in front of a parenthesis, multiplication is implied. Plus, the problem says multiply. But I'm not kidding you. This has happened several hundred times in my lifetime, my career, where I say multiply and the student accidentally subtracts because they see a minus sign, even though the question clearly said multiply. Remember, this is basic general principle of this class. Whatever can go wrong, it will go wrong. And it will go wrong at the worst possible time when you can't afford to lose those points, right? So keep that in mind, all right? Make sure that you know you are not subtracting, you are multiplying. So you have a positive times a negative, so you already know your answer is going to be negative. And now you can just do the problem. 14 times 12, 9 times 7. 14 is 7 times 2. 12 is 3 times 4. 9 is 3 times 3. And 7 is already prime. If there were more 2's, then I would keep going with the 4 and break it down even further. I would break it down into 2 times 2. Right? In fact, I could do that. It's not going to stop me. But since there are no 2's in the bottom, none of the 2's are going to cancel. Only the 7's and one pair of 3's. So the answer is -8. 2 times 2 times 2 over 3. -8/3. We're almost ready to go to division. Before we do division, we're going to do exponents. So 2/3 squared. 2/3 squared means 2/3 times 2/3. Or you can write it this way. 2/3 parentheses 2/3 around both of them. It really doesn't matter. Tomato, tomato. You're going to multiply straight across. Either way you slice it, you're going to get 4/9. Now be careful with this. This is already simplified. And I know I give you a lot of these warnings because I don't want to see the thing that I've seen so many times that I could just stop you from doing it now. 2/3 is simplified already, all right? If you start with a simplified fraction and then you square it, your answer will always be simplified already. All right? Don't try to then simplify 4/9. I have seen people do this, and it really breaks my heart. Yeah, that's incorrect. I've even seen people do that. In other words, I know what's going on. What's going on is you have this desire to satisfy, to simplify, to reduce, right? You want to make sure that you're doing it right. And so you get to this step and you look at it and you go, oh no, I need to simplify it. I got to do something. You don't have to do anything, okay? When I give you an exponential that's already simplified at the beginning, right? Now that's the key. It has to already be simplified at the beginning. Then the final answer will already be simplified. You'll never have any extra work to do. The worst thing that could happen is you could end up with negatives. This is the worst thing that could happen, negatives. I'm waiting for my computer my camera. Come on back to me. There we go. Oh, that was easy. Why can't I just do that every time? All right. Be careful with negatives. All right. If this is an even power, then the answer is positive. If it's an odd power, the answer is negative. It really has to do with the power. So this is going to be a negative times a negative, so the answer is going to be positive. 5 times 5, 6 times 6, so 25/36. And again, don't try to reduce that. It's not ever possible. It's always irreducible. All right, this is an odd power, so the answer is going to be negative. 5 times 5 times 5, 6 times 6 times 6. 5 times 5 is 25. 25 times another 5 is 125. 6 times 6 is 36, times another 6 is 216. And again, that might look like you need to simplify it. I don't know, but it kind of does. It kind of looks like it. Don't waste your time trying to simplify something like that. Okay. Next example. Geometry. So triangles. We've already talked about rectangles and parallelograms. We've talked about perimeter and area. But next we need to talk about the area of a triangle. Yeah, the inside. Come on back. Start over. There we go. So we want to know how much area is inside of a triangle. Okay. This type of triangle is called a right triangle. And so this is half of a rectangle. Yeah, see? Here's the whole rectangle here. Okay. So if this is B for base, and this is H for height, the area of a rectangle is BH. Yeah? Base, B. I know it looks like a 6. I got to be careful. Height, H. So base times height. Multiply with a dot. So since the triangle is 1/2 of a rectangle, the triangle area is 1/2 times B times H. Or if you prefer, you can get rid of the dots and just say 1/2 BH. You could also do it this way, BH over 2, and don't even write the 1. Yeah. B times H divided by 2. So this is the area of a triangle. So I don't care about this piece here. I'm just doing the triangle. So it's as if the rectangle has been cut away into 2 triangles. Okay. So this is the formula, the general formula. Let's do an example of that. I lost track of where I'm at. I think I'm up to 15. I don't know. I've been doing this too long now. So if this is 8m and 7m, m means meter. That's a pretty big triangle. 7 meters is over 20 feet. Yeah, it's about 21, 22 feet. 8 meters is about 25 feet. So I want to know the area. That's 1/2 8 times 7, or 8 times 7 divided by 2. Doesn't matter. You're going to get the same answer either way. I actually like this version of it better. It's nicer. So that's going to be 56 over 2. Reduce that if possible. That's 28 meters squared. Or you could say 28 square meters. Again, I've mentioned this before. At the end of the semester, it'll probably be in December sometime. We're going to do a whole section on meters and feet and inches and miles and kilometers and all that. And when we get to that point, I'm going to be really picky about whether or not you know the meters and the feet and all that. Today, I don't care. I just want you to know that it's 28. Okay. It will say square meters. Be careful that you don't accidentally square your answer. I've seen people do it right, get the right answer, read it one more time, and then accidentally screw up their answer that they got. Okay. Let's do another one. Some triangles are not half of a rectangle. Some triangles are half of a parallelogram. So something like this. All right. Sorry, I didn't draw that very well. Okay, what do I mean by half of a parallelogram? A parallelogram looks like this. So this is a parallelogram. It looks like a rectangle that got kind of saggy and kind of leaned over, right? This sometimes happens with bookshelves. I don't know if you ever had a really old bookshelf and it's so old that it just sort of leans like that. Or you can do this with an actual book. You can kind of push on one edge of the book and it'll kind of turn into a parallelogram. So in this case, you ignore this side and look inside for the height. So this is not going to be the height when it's a parallelogram. The height is going to be inside. It'll look usually like a dotted line. I don't know why I'm screwing it up. There it is. And there's your there's your H. Okay, so look inside to find the height. I always think of it like a tent. Yeah. If this were a tent, like you're going camping, the height is the pole in the middle of the tent. I know they make tents differently now, but when I was a kid, the tents had these poles in the center of them, and you had to be really careful that you didn't get up in the middle of the night to pee or something and accidentally kick over that pole, and the whole tent comes crashing down. Okay, and then the base is this entire side here. That's your base, B. The area is still the same formula, 1/2 BH or BH over 2. Same formula. Okay, and again, this side over here has been cut off. That's why we're taking half. So imagine you have a whole parallelogram and you chopped off this half. What you're left with is a triangle, and that's what we're finding the area of. Okay, find the area. Ignore, ignore. All you want is the base and the height. All right. So the area is 1/2 8 times 6, or 8 times 6 divided by 2, which is 24. And I don't care if it's 24 feet or 24 meters, it's 24 square units, where the unit is however you're measuring your triangle. In example 15, I was measuring it with meters. In this one, I didn't specify, so it's just generically units. All right, that's it for multiplication. We got to do division. I know I say this a lot. I have to say it. It's almost like my obligation to say this. Vocabulary is everything in this course. Math is really, math is important. I want you to learn the math, but learning math without knowing what you're talking about is useless, right? They go together, right? Reciprocal means flip. Does not mean opposite. And I get students that have gone through many, many years of math. They get up into calculus and they still say the wrong word. And it becomes totally self-defeating if you can do the math, but you can't say the word properly. Reciprocal does not mean opposite. But there is a thing called the opposite. The opposite means to change the sign, right? So a positive becomes a negative becomes a positive. But reciprocal means flip over. So the reciprocal is 8/7. I don't really care how you draw the line. It could be horizontal like that, or you can make a slash kind of thing. So notice it's been flipped. Okay. Do not change it into a negative. So for this one, the reciprocal is 3/1. Since the 1 is in the denominator, we omit, and you just say 3. Do not change it into a negative. This one's already negative, and there's an invisible 1 in the denominator. If you don't see a 1, it's invisible, just like here. Yeah. So when you flip it, now it's in the top, and the -4 is in the bottom. I would just write it like this, and since it's in the top, you cannot omit it. That says do not. Do not omit. All right, so you must put the 1 here. If you really want to, I would not mark the answer wrong if you left the negative in the bottom. I know I've said that before. But I like to either put it out in front or I like to either put it up top. If you like to keep it in the bottom, that's fine. I can't punish you for it. I can't take off any points. I mean, even if I could, I probably wouldn't, but I'm not going to. So, okay. We got to wrap this up pretty soon. Division. So those are reciprocals. Got those done in one example. Division means multiply by the reciprocal of the divisor. So if you have A divided by B, A is called the dividend. B is called the divisor. The divisor is on the right-hand side. Dividend is on the left side. In this section, in fact, in this entire chapter, A and B are fractions. I know they don't look like fractions right now the way I've written them, but they are going to be fractions. Oh, God, what am I up to? 18? Starting to lose count. All right, so this is A. That's dividend. This is B, divisor. Okay, so division means multiply by the reciprocal of the divisor. So we change the division symbol into multiplication, and we change the divisor into the reciprocal of the divisor. So you're never actually going to divide. You're going to multiply. I love that. That means I don't have to spend the last 10 minutes talking about a new rule. It's the same rule that we just learned. You're just going to do it with the reciprocal. So 8 times 3, 9 times 16. We've already done these kinds of problems. 8 is 2 times 2 times 2. 3 is already prime. 9 is 3 times 3. 16 is 2 times 2 times 2 times 2. This is getting really messy here, so I'm going to come up here. So I've got 2 times 2 times 2 times 3, and 3 times 3 times 2 times 2 times 2 times 2. I'm just bringing it up here so you can see better. And then now cancel as much as you can. So we have a 3 and a 3. We've got 2 and a 2, 2 and a 2, 2 and a 2. Everybody canceled on the numerator, so that becomes 1. And then the bottom is 6. And so the result is 1/6. Okay, 6/7 divided by 15. Let's make it a negative. I want to get one of the negatives done now. I notice we're getting really close to the end here, so get some negatives done. All right, so that would be negative 6/7 times the reciprocal of 15, which is 1/15. All right, it's a negative times a positive, so I know the answer is going to be negative. 6 times 1, 7 times 15. Let's factor this out. 2 times 3 times 1, although I don't really have to put the 1. Remember, you only have to put the 1 if it's the only one left, then you have to put it. 7, and then 3 times 5 is 15. And it looks like we're only going to get one pair. That's the 3s. So 2 times 1 is 2. 7 times 5 is 35. So you get negative 2/35. Don't worry, we're almost done. Hang in there. Okay. So remember, dividend on the left, divisor on the right. Change to multiplication and find the reciprocal of the divisor. I don't really care where you put the negatives right now. You can put them on top, you can put them on the bottom, you can put them out in front. It really doesn't matter, because once you know that there are 2 negatives, you already know the result is positive. So you could just cross off those negatives. Those are gone. So now you have 11 times 9, and you got 3 times 22. 11 is already prime. 9 is 3 times 3. And 22 is 2 times 11. So the 11s are going to cancel. And one pair of 3s is going to cancel. And your final answer is 3/2. All right. We're almost done. I know I keep saying that, but I got a couple more things to say. Note, if the divisor is 0, then the quotient is undefined. And I want you to put DNE for undefined. It's an acronym for does not exist. All right. Only if the divisor is 0. So this is just one that you're going to have to memorize. If the divisor is 0, then the answer is a free answer. It's D and E. Okay. If the dividend is 0, and the divisor is not, then the answer is 0. So if the dividend is 0 and the divisor is not 0, then the answer is 0. Anytime the divisor is 0, it doesn't matter what the dividend is. Yeah, you can just ignore that. As soon as you see a divisor of 0, you get a free answer of D and E. I've been really lazy with the instructions. I think at the very beginning of the lesson today, I pretty much gave all the instructions for the whole lesson, but they're all basically the same. Simplify, evaluate, reduce, lowest terms, etc., etc. Okay. Dividend is also called the numerator. Divisor is also called the denominator. Okay, so this time the dividend is 0, the divisor is 6, and so the answer is just 0. That's your answer. Here, divisor is 0. Dividend is not 0. I like to spell dividend with a capital D, because these both start with the letter D-I-V, letters D-I-V. In fact, D-I-V-I, D-I-V-I. They're so easy to get them screwed up. Divisor is the bottom, the denominator, and so this is D and E. I'm going to end it here. If you want to be the life of your next party, I'm just making a little comment here. I mean, this might be on the test though, so you should definitely know this. I love this one. Next time you have some family over, maybe Thanksgiving or something like that. If you manage to get your family or friends together, I know you're not supposed to have too many people over, but it's just fun. And if you don't want to do it in person, you can just do it over the Zoom or talk to them or whatever. Ask your friends, what is this? I do this all the time just to mess with people. In fact, I think I just did it a week ago. I had my mother-in-law was over, and I had to try it on her. Most people will say 5. Yeah. In fact, try it. You can try it at the store. You can try it anywhere you run into somebody. What's 10 divided by a half? Most people will say 5. Right? It's just human instinct, because human instinct is 10, half of 10, and your brain says it's 5. Yeah. But that's not correct. All right. A common incorrect answer is 5. And that's not right. But it's so common. I'd say about 80 to 90% of all human beings will say 10 divided by a half is 5. The correct answer is to use what I've been teaching this entire second half of the lecture. 10 divided by a half is equal to 10 times the reciprocal of a half. There's an invisible 1 in the bottom. So 10 times 2 is 20. 1 times 1 is 1. And 20 over 1 is just 20. That's the actual answer. Now, I don't want to get anybody in trouble. I don't want anybody having a family member that hates you, but this is the type of mathematics that language becomes so important. If you're speaking the language of math correctly and you translate it into symbolic language and you evaluate it properly, you will get the right answer. But if you just use your instinct, if you use your knee-jerk reaction, and you say 10 divided by a half, it's 5, you'll get it wrong every single time. Okay? So that's more than just a fun fact. This type of problem will more than likely occur on a quiz or a test or something, because I want you to learn the language of mathematics as well as the actual process of mathematics. I've gone on for an hour and 20. That's a normal class period, by the way, if you've ever had my class in person. So until we meet again, this is Dr. Jordan. I'll see you on the internet.